Okay, both of the examples we've done previously, integrating by substitution, did not involve limits. They were indefinite integrals. So what changes if we involve limits? So there we go. The integral from 0 to 2 of t over square root of 5 plus t squared dt. Now, whenever you come across an integration problem, you first look and you imagine, can I use the power rule on it? Okay. If you can't use the power rule, then you know that you're probably going to try substitution. That's your next step. And so that's kind of where we are on this. This looks way too complicated for the power rule. So we're going to try u substitution. We're going to choose our u. And again, we're going to choose the inside function. And we just take a quick glance at the derivative, which would be 2t. And look, there it is. We've got a t and we've got a t. So the derivative of this inside function is right there. So it looks like things are going to work. Of course, this leads to the fact that what we need is dt. dt equals du over 2t. Okay, and now we're ready to make the substitutions. So I've got a t, I've got a square root. I'm going to, we'll just write it like that. Square root of u. I know that'll be u to the 1/2. And then dt is du over 2t. And look, I can cancel the t's. And I'm in terms of u. Now notice, I did not put my limits there. It would be wrong for me to put 0 to 2 there. The reason is because those are t limits. Now my integral is in u. So I have two routes to go here. I can choose either one. I'm going to show you I'll just show you the most direct route, and then I'll show you the nice, clever, and probably best route. Okay. So, in other words, what I would do is this first route that I'm going to show you is just to continue down the path that we've already established. So, this is the integral of du over 2 squared u, but if I rewrite that, 1/2 integral of u to the minus 1/2 du, right? Because that's what the 1 over square root of u is. And I integrate it. Notice I'm not putting limits there because these are all u's. And so it's going to be 1/2 u to the 1/2 over 1/2 du, not du, the du is gone, plus c, because we've now integrated it. And I could flip that 1/2 or cancel those 1/2s, but either way, those are going to both disappear. And so I'm left with u to the 1/2 plus c. Now I convert it back to x's, or t's. 5 plus t squared square root plus, I've been putting this plus c. I don't need the plus c because this has limits. So just ignore all the plus c's. So 5, I return to the t's, and I get the square root of 5 plus t squared. Now I can throw in my limits evaluated from 0 to 2. And we know what that means. We plug in the 2 first, so we're going to get the square root of 9 minus the square root of 5, or just 3 minus square root of 5. Okay? So that's the way that, fits best with what we've been doing. We change to u's, and then we integrate, return back to t's, and then we use limits. But there's a better way, and that is, again, after you've done found your u and your dt, and you substitute. Okay, so let's pick up. I'll do this one in blue. So let's pick up. So we're going to have t over square root of u, and then for dt we plug in a du over dt. Okay, over 2t. And the t's are going to cancel, right? Like we expected. Now we're just down to u's. So here's what we can do. I can actually change my t limits to u limits. So my t limits are 0 and 2. Those are for t's. But if I want to change them to u limits, I just use this formula. So when t is 0, plug 0 in there, u is 5. So I can put a 5 right there as my lower limit. When t is 2, plug 2 in, I get u is 5 plus 2 squared, 9. So my limits change to run from 5 to 9, and now those are u limits. And the advantage is this. I don't have to ever return back to t's. So it's 1/2 integral from 5 to 9 of u to the minus 1/2 du. And when I integrate that, I get a 1/2 u to the 1/2 over 1/2 evaluated from 5 to 9. The 1/2's cancel. And so now I'm just ready to plug in the 9. So it's 9 to the 1/2 minus 5 to the 1/2. And look at that. That's the square root of 9 minus the square root of 5, which is 3 minus square root of 5. Same thing. So this is the best route because we just changed the limits using our simple little formula. And then I never have to resubstitute like I did back here, change back from u's to t's. Now either way works. You can see I get the same way, but we typically like this way because I just changed the limits to u limits.